Alright, in this video we're going to do two examples and they're both in this form. We've got sine to a power, cos to a power. The first example we're going to do is when at least one of these are odd. Okay, so like 3 here is an odd number. So if they're both even, it's a real pain. We'll do one of them next. This one's not so bad when you've got one that's odd. Okay, so the strategy for this one, now I've written some identities over here for later use because all these identities are really useful when doing these integrations. Okay, so the strategy here, when you've got one that's odd, at least one. If both are odd, you would still use this strategy, but if one is odd, then you break it up. You break up the odd so that you've got one left out. Okay, so this cos, what I mean by break it up, is going to take one of those. I've got 3 of these to use. I'm going to use one of them over here, then write out the rest. So sine of 4 2x, cos of 2, because I've got 2 left. I've used one of them, put them over here, break it up. Okay, now what I'm going to do is take this one and turn it into sine. Now the way to turn it into sine is to use the top formula, sine squared plus cos squared equals 1. Okay, so that Pythagorean identity, turn this into a sine. So the only cos left over is this one. Okay, the only one left over that we've broken up. Okay, so we've got sine of 4 2x times, now cos squared is just 1 minus sine squared, 2x, using that Pythagorean identity. I'm going to expand that out. Cos of 2x times bracket. So I've got, if I expand this into the bracket, sine of 4x times 1, so sine of 4 2x minus sine of 4 times sine squared, I get sine 6 of 2x. You're thinking, this is getting more complicated. Why are we doing this? Okay, the point now is to make our substitution. So what substitution we're going to do? We're going to do a sine substitution. So let u equal sine of 2x, okay, because du dx is going to be 2 cos of 2x, right, which is why we left this cos here, right, so that we can use this substitution, okay, to change it to u. Okay, so now I've got 1/2 du dx. Let's just stick the half straight out the front. We're used to this now. So this is going to change to a u. I can leave this off because this is du dx. That dx is going to cancel. So now I just have u to the 4 minus u to the 6 du after that substitution. Okay, so that's lovely. That came out really nice. So now I just go 1/2. Now I'm on easy street, yeah? 1 on 7 u to the 7 plus c. Substitute back in. What have I got? I've got 1/2 times 1/5 of sine to the 5th of 2x. Okay, minus 1/7 sine to the 7th of 2x. Got a plus c on the end there, and we're done. Hopefully all that's in the camera view. Yeah, I think that looks fine. All right. Okay, I think we're done. Do I want to expand that out at all? Let's have a look at what answer I got. Oh, well, I expand the half in, but nothing better than that. So let's leave it at that. Okay, so that's the first example. Now that's the easy example. Okay, this next example, I think I've purposely chosen quite a difficult one. So I'm going to change this to a 4. So let's make them both to the power of 4, and let's just make this a 3, just to change things up just slightly. But basically it looks the same. However, now we've got both even functions. So when you've got both are even, not even functions, you know what I mean. These powers are both even numbers. Okay, so what we're going to have to do is we're going to use our double angle formulas to try and get them down to where they're not to any power anymore. Okay, so we're going to try basically use these ones down here, these rearrangements of the cos2 theta, yeah, as much as possible. And you know, maybe this double angle formula as well for sine, because we've got a sine in there. Okay, so if we're going to do this, how do we step into this? Let's take, here we go, first step, we're going to have to go over here a bit more, I think. Let's just leave this for now. Well, actually, let's do this first. I think I did that wrong last time. Or just have it not working. Where do I want to start? All right, let's just make a start. Okay, so let's go with, leave that. So sine of 4, 3x. I'm scared, I don't want to make a mistake. Who cares, just make a mistake. That should be my attitude. Who cares, just do it. Okay, so I've taken out the square from this bracket. So now I'm using this. I've got cos squared. Now I know cos squared because I already rearranged it here to get in terms of cos2 theta, because I knew that I was going to struggle to do that on camera. Okay, so let's go sine of 4 of 3x. Cos squared is the same as this, so I'm going to plug that in. 1/2 of 1 plus cos of 2 theta, so I'm up to 6x. And this is squared. Wonderful. Okay, so what am I going to do with that? I am going to then expand it out. So I'm going to bring the 1/4 all the way out. So I get 1/2 squared, 1/4 all the way out. Let's do this one. So what do I get here? I should get sine 2 theta. We've got this one to the power of 4. So what do I have? I've got all this to the power of 4. So I want, if I've got sine of 2 theta, which is sine of 6x, all over 2 cos of theta. Rats, I didn't see that coming. Let me try again. Alright, so this is right, I think. Yeah, so I've rearranged this one. I just didn't see this coming. I've mucked this up a little bit, but perhaps I shouldn't have started with this step. Okay, so this is not wrong. Let's go back a step, just because I've seen what I think is a better option here. Let's go back up to cos here. So now let's just forget I ever did both of these steps. Okay, let's forget I did this. Okay, now I'm back up to here, and I've gone cos of 4 3x. Right, just rearrange this one, because now what do I get? I get 2 to the power of 4, bring that out the front, 1 on 16. Okay, so now my cos of 4x is going to cancel out with that one, and I just end up with a sine to the power of 4. This may have worked, but this looks much better. Maybe much better. Okay, I'm pretty happy with that. Pretty happy with that so far. Should we I'll tidy up. I'll tidy up. I'm going to rub this out. Just remember this bit. I'm going to write it back up at the top because I've still got a few more steps to go. So 1 on 16 sine of 4 6x dx. Hopefully I wrote that out right. Okay, I think I wrote that in my book. Alright, so now we've done that. Now what are we going to do? We are going to write this in terms of cos. I feel like most of these ones, we want to get them down to cos. You know, sine is no good to us. Let's get them down to cos. So we've got, okay, we've got, well, this is just sine squared of 6x, all squared, dx. And sine squared is equal to this one. So we've got 1/16 of, let's do a square bracket. We've got 1/2 of 1 minus cos of 12x now. Yeah, that's it. No squared there, don't forget, don't get it wrong. That's why I had to write these down earlier. Okay, dx. There's still a squared out the top here. Don't forget that squared. It's still there. Okay, so I can square that. I've got 4, so now I've got 1 on 64 out the front, half squared. 1 times all this squared, so now I've got 1 minus 2, I'm expanding the brackets, cos of 12x, this is squared, okay, plus cos squared of 12x. We're almost there, dx. We haven't done the integration yet, but it's a lot of working without actually doing the integration. Okay, this cos squared, I'm going to do this again. Oh, this one this time. Okay, we'll do that. Okay, 1 on 64. 1 minus 2 cos of 12x plus 1/2 of 1 plus cos of 2 theta. I'm up to 24x bracket dx. I'm running on a bit of an angle here, but that's okay. Now I think I can do the integration. So I've got 1 on 16. I'll just tidy up a little bit, but some factors here I can do. I can go 1/2 plus 1. It's 3 on 2. It's hardly worth it. Cos of 12x plus 1/2 of cos of 24x dx. Now they're all back to single powers. And so we just integrate that, all of those. 1 on 16 gives me 3x on 2 minus 1/6 of sine, because I've got to divide by 12 here, of 12x. I've got to divide by 24 here. So I'm going to get 1 on 48 sine of 24x plus c. Let's stick with that. Oh, gee whiz, that was a tough one. Okay, that'll do for this video.